So today we're going to begin looking at how to draw Lewis structures for covalent bonds or covalent molecules. All right, so let's review. A covalent bond is formed when electrons are shared. Now there's three types of covalent bonds. We can have a single bond, and this is going to have two electrons that are shared. It is also the longest of the bonds, and it requires the least energy to break. We have a double bond, which shares 4 electrons. And we have a triple bond, which shares 6 electrons. It is the shortest of the 3 bonds and requires the most energy to break. And you'll notice here my symbol for single, double, and triple. So each line represents 2 electrons. So a double bond has 2 lines, so 2, 4 electrons. A triple bond has 2, 4, 6 electrons. So let's get our rules down, and then we'll try and make sense of what these rules actually mean. Atoms are going to share electrons in order to fulfill the octet rule. And of course, in chemistry, we always have to have exceptions to rules. Okay, the only rule in chemistry is there are no rules. So some exceptions here are going to be 1A, group 1A needs 2 electrons. Group 2A needs 4 electrons. And group 3A needs 6 electrons. All right, our second rule. Group 1A and 7A must always be on the outside. Carbon. Carbon will always go in the middle. Rarely do you ever hear me say the word always. Carbon always, let me underline that, goes in the middle. All right, electrons are being shared, therefore they belong to both atoms when in a bond. The number of electrons in our final structure must equal the total sum of the valence electrons. And finally, we want to make our structure symmetrical if possible. All right, so here's our rules. So let's see what we can do in terms of drawing covalent compounds. Let's do a couple of examples and try and make our rules make more sense. So let's start with water. Step 1, we are going to count our valence electrons. So hydrogen has 1 valence electron. I'm looking for my periodic table. All right. Sorry, friends, I had to find my periodic table. Hydrogen has 1 valence electron, and I have 2 hydrogens. So we're going to multiply the 2 hydrogens by their valence electrons of 1, plus the valence electrons of oxygen. Oxygen has 6 valence electrons. So the total number of electrons in my structure cannot exceed or go below 8. 8 is the magic number. I cannot have less, I cannot have more. We will always start with a single bond. So hydrogen is in group 1A. Group 1A goes on the ends. So I'm going to put oxygen in the middle. Now also hydrogen is in group 1A, and remember group 1A needs 2 electrons. This is why it goes on the end, because it can never be in the middle and have more than 2 electrons. All right, so we add in a single bond. Each hydrogen now has 2 electrons. My structure so far has 4 electrons. I need to put in 8. So now I'm going to add in lone pairs. So we do a single bond and we start adding lone pairs. 6, 8. Now we're going to check our work. Hydrogen has 2. Oxygen has 2, 4, 6, 8. And hydrogen has 2. So everything in this case is happy. So this is what water would look like. Let's look at oxygen. Oxygen has 6 valence electrons. There are 2 oxygens. So my structure needs 12 total electrons because it has 12 valence electrons. We are going to start with a single bond. So I've put in 2. Now we are going to add lone pairs until we get to 12. 4, 6, 8, 10, 12. Let's check our work. The oxygen on the right has 2, 4, 6, 8, so it is happy. The oxygen on the left has 2, 4, 6. It is not happy. It needs 8. So here's where students mess up. The very first thing we are going to do is erase, then we draw. Okay, friends, so we have to have 12 total electrons. So we have to arrange these electrons somehow that both of these atoms of oxygen have 8 valence electrons. We're going to do that by forming a double bond. I am going to remove a lone pair first. Remove a lone pair first, then I will draw in the double bond. So we start with a single bond. If we cannot get our octet rules to be fulfilled, at that point we move to a double bond. If a double bond doesn't work, only at that point do we move to a triple bond. So my oxygen has 2, 4, 6, 8. And this oxygen has 2, 4, 6, 8. So the octet rule has been fulfilled. So this is what oxygen looks like.